I'm going to evaluate this integral, evaluate the integral for inverse of trigonometric function. Alright, for this function, I'm going to let the theta to be arc sine of x, which I'm using a substitution function. Okay, now I'm using a substitute function. So then I will know that sine theta will be equals to x, right? So theta is the inverse of sine x. So definitely the sine theta will be equals to x. As you must know that arc sine x is a one-to-one function, alright, one-to-one function. So previously I got talk about the inverse function for trigonometric function where the graph is a one-to-one function. Okay, so then I'm going to differentiate this, or I can rewrite this x to be sine theta. So the dx d theta will be equals to cos theta, right? Cos theta, then the dx will be cos theta d theta. So now I can trying to substitute the function in terms of theta. So dx can be substituted with cos theta d theta, cos theta d theta, whereas the inverse of sine x can be replaced by theta, right? Can be replaced by theta. So of course that this is from x equals to 0 equals to x equals to 1, right? So for the limits here, you also have to change the value according to the function that you use as a substitution function. So when x equals to 1, so when x equals to 1, so theta is equals to arc sine of 1. Because of the inverse function of trigonometric function here is a one-to-one function, so the angle produced, you are getting an acute angle, right? So you're getting pi over 2, right? Because you know that sine pi over 2 is 1, sine 90 is 1. So when x equals to 0, so theta will be arc sine of 0. So you substitute 0 inside here, so you're getting theta is 0. So it means that you can replace the limit. When x is 1, it's pi over 2, right? When x is 1, this is pi over 2. So when the x is 0, the theta will be 0. So now I have replacing that from theta equals to 0 to theta equals to pi over 2, from x equals to 0 to x equals to 1. So now I'm going to apply integration by parts for this, okay? Integration by parts for this, where is u equals to theta and the dv equals to cos theta d theta. So du d theta will be equals to 1 and integrate both sides, okay? For this I integrate both sides, I'm getting v equals to integrate cos theta, you're getting sine theta. So then you know that du will be d theta and v equals to sine theta. So the formula for integration by part will be uv, u dv, right? Your u dv, which is this is your u and this is your dv, will be equal to uv minus integrate v du. I apply integration by part for this. So then I have u, which is theta, v sine theta, alright, sine theta minus integrate v, which is sine theta, right, your v sine theta, du will be your d theta. So because there is a limit here, so I'm going to put 0 to pi over 2 and this also 0 to pi over 2. Okay, now you can pause the video and try to evaluate this. So then you can substitute the pi over 2 sine pi over 2 minus with 0 sine 0, right? For this bracket here, evaluate. And whereas for this, we integrate sine theta, you are getting negative cos theta, right? Negative cos theta from 0 to pi over 2. As you can take out the negative, right? Factorize the negative, you are getting plus here. Okay, so we continue evaluating pi over 2, sine pi over 2, and this will be 0. okay, this will be 0, plus with cos. Substitute, you're getting cos pi over 2 minus with cos 0. So from here we know that pi over 2, make sure that you're calculated in radian mode, alright, your radian mode, your angle units have to be in radian mode. Sin pi over 2 is sin 90, which is 1, alright, 1, whereas cos pi over 2 is 0, cos 90, and cos 0 is 1. So finally you will have pi over 2 minus 1. This will be the value for this integral. Alright, evaluate this integral. That's all for this video. Hope you understand.